Okay, Jam, on today's episode, we're going to be talking about, I'm so excited for this.
Okay.
More excited than I've been in a long time.
Interesting.
About thermometers.
Ah.
Do you already know how they work?
You know what? I think I know how old school ones work.
Okay.
But I honestly think we got a question in a Q&R about that a long time ago. Like mercury.
Oh, did we?
Mercury thermometers, something like that.
Okay.
So I think I have that version of a understanding about it.
Okay.
But not about electronic ones or any other type of ones.
Well, we're going to talk about the old school ones. We're going to talk about the ones that point and swivel like your oven thermometer.
Okay.
And then we're going to talk about, it's going to be a two-parter. We're going to talk about more stuff next week about how we got Fahrenheit and Celsius and possibly infrared thermometers.
Okay.
As well.
Interesting.
So we got all kinds of things going for you.
Sounds great.
Are you excited?
I'm very excited.
I'm very excited too. Okay, let's get into it. Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
For some reason, I want to say bonus edition, but it's like thermometer edition.
Well, how about this? If this is one of your first times joining us, when we say Melissa's a chemist, she truly, really is.
Mm-hmm.
And I truly, really am not. Melissa has a bachelor's and a master's and PhD.
So much school.
In chemistry. I don't. And every time that we have these conversations together, Melissa teaches me something about chemistry that I do not know. And I'm learning it for the first time, just along with you.
Yeah.
So,
and we have Jim here asking questions in case, sometimes I don't see things from a different perspective because I've been in science for so long. So it helps that he can ask those types of questions. And if you still have questions, you can write them in and we'll address them on a bonus episode.
And I'm also here to try my hardest to work a joke in wherever it might fit, even if it's a really not great fit.
That's Jim's whole job. He doesn't do anything else. He doesn't do the audio, visual, editing. All he does is make jokes and learn.
That's right. Yep.
That's not true.
Easiest job ever.
Okay, so this question, it actually did come when I posted on Instagram asking for questions for bonus, and our friend / patron / Letila / chemist Letila friend that we made through the show.
Yeah. / Letila.
Came in and asked what the chemistry of thermometers was. And I took the response, when someone asks a question on Instagram, you can post a response.
Oh, yeah.
And I said, ooh, that's a really good question. And then somebody else, Ebony, commented and said, ooh, that is a really good question. So I was like, okay, we got to do this.
Nice.
It's time.
That's
so
great.
Shout out to Letila, shout out to Ebony, and shout out to thermometers because this is really exciting for me.
That's awesome. I'm into it.
Also, just full disclosure, we're recording ahead of time to get ahead for the holiday season and whatnot. And so it's like hard to crank out a new episode every week.
Mm-hmm.
And I haven't had a lot of time to wonder or get excited. And so this question made me so excited, more excited than I've been in a while about recording an episode. So I'm really happy that we're doing this.
Nice.
And I think it'll be a short, sweet, and also a fun two-parter.
Nice.
Because we're also going to talk about what even is Fahrenheit and Celsius next time.
Okay, cool.
Okay. So, you think you know how the old school, like the bulbs with the mercury, bulb thermometer with a mercury inside of it. You think you know how that works?
I think so.
Okay.
I think I remember. I'm like, I wish I could go look in our show notes and stuff like that to find when we talked about this in a Q&R. But like, that's the memory I have. But I just, can't quickly do that. But here's what I remember you saying. So in my memory, this info originates from you. I just can't prove it yet.
I believe that I said it, but I don't remember it.
That the mercury thermometers and ones like that would be just calibrated in a way that as the temperature outside, or I guess inside even, wherever you have the thermometer placed, would, as it's warmer, the liquid would expand.
Mm-hmm.
And we know that that's how things work anyway. Like all types of substances, warmer, they have more energy, more room to move around and take up more space. Colder, kind of condense closer together, less energy. Molecules going closer and closer, less space between them. And that essentially, depending on what substance is in one of those types of thermometers, they've just figured out how to make sure that the amount that's in there corresponds to the amount of change based on the amount of heat that's changing. So it's
Right.
like just kind of nailing that, I guess, is the key.
Yes,
right?
that was such a good description. I kind of, once Mason knew the answer, I kind of hoped that you would also know the answer, because what's fun is I don't think Jim would have been able to answer that at all before we started this podcast.
Right.
I don't think you knew to even think about what was happening at the molecular level in something,
Right.
or that you knew that the more things warm up, the more energy is in them, the more they move, and then they expand.
Yeah, I think I had like maybe just a rudimentary idea of like heat can make things expand and cold can make things contract.
Mm-hmm.
But I don't think I really could explain beyond that or deeper than that.
Yeah.
And I also don't even know I could pull that many examples. I think I'd just be like, oh, that's just what I've heard,
Yeah.
you know?
Yeah. That's so exciting. So I 100% agree with what you said. I'm just going to recap quickly. I love the analogy we've used several times of like, you know, if you have a bunch of kids in a room and they're all sleeping, maybe they would take up their little space of how much they were sleeping on their little mats at nap time. Low energy, low space taken up. Just like this much space off the ground in however much room, you know, it takes to lay a bunch of kids down for their naps. But then if you feed them a bunch of food and get them really excited about something and let them run around like crazy, they're going to take up a whole room, a whole house even. I'm over here with Jam's kids and one of our other friends' kids, and it's like they're taking up every space that they possibly can, just like electrons, or not just electrons, just like molecules will. As the more energy you put in, the more they're going to move around. So that is the idea behind thermal expansion. As things get more energy put in, they get larger. And yes, that is exactly what the old bulb thermometers are, is they have usually, I think I'm going to make you guess what they have. They have something in them that is calibrated that, as it warms up to this temperature, it's going to get to this spot. So we'll put a line right there. And, it just goes up and down with the temperature. That's a perfect example. So we know it's not mercury in them anymore most of the time. It's either like a blue or a red liquid. Mm-hmm. There's no mercury because mercury is toxic, and when they break people with it, not good. Mm-hmm. So what do you think is in the thermometers now? Or what do you think is not in the thermometers now?
I think... Dang. I mean... That's tough.
It is tough.
Like, needs to be a liquid
Mm-hmm.
from basically like, what about alcohol?
Why do you think it's alcohol?
It doesn't freeze as easily, right?
Yeah.
Because you need it not to freeze so it can get lower and lower and lower temperature.
Yeah.
You also need it not to boil off too easily, right?
With the pressure, doesn't really matter.
The pressure is pretty tight in there, right? So,
yeah.
But you need it not to get out of hand completely if it gets too hot, right?
Well, that part, I think, at some point, if it gets hot enough, they can explode.
Right.
So there's a safe range to use them within.
Right.
Because if you heat a closed container,
the bomb.
That's a bomb. And the thermometer is a closed container.
Right.
So there is a range at which the pressure can go, and there's thermometers rated for certain things. I've seen thermometers explode in the lab before. It's crazy.
Ooh, that sounds yeah.
It is wild. Yes, alcohol. Most of them have alcohol in it. Good job.
Nice.
And that's exactly what I was going to say is alcohol, you need it not to freeze. And so it can go down to, they have specialty ones that are other things than alcohol, but you need it not to freeze. So it can go down below the freezing point of water and still measure. So that's one reason that water's not in it. Oh, and they usually just color it to make it easier to see. Mm-hmm. So that's one reason that water's not in it. Can you think of another reason why water might not be in it?
Why water might not be in it? I mean,
other than freezing. Say it's an above freezing thermometer.
Okay. Well, we know that water does thermally expand. We talked about that in sea level rise. So, like, we know it does that.
You're so close. I'm just going to give it to you.
Okay, tell me.
It does thermally expand, except for in the 4 degrees Celsius between 0 and 4 degrees. Because when water forms a crystal structure, there's a lot of space that forms. It
Right.
has to make those hexagons. We've talked about this
you're talking
before
about
on our
Celsius.
snowflakes episode. Oh, yeah, Celsius.
Yeah.
0 and 4 degrees Celsius. Sorry.
Right. So, it still has to do with the cold though, right?
Mm-hmm.
Okay. I was trying to think about other properties.
Yes. So it still expands a little bit as it gets colder, unlike other substances. So there would be a range where you could not accurately use a water thermometer because it would start going up even though the temperature was going down. So it doesn't act like everything else. Everything else, you can pretty much say as it gets warmer, it expands. But water is one of those things that it has a little tiny exception.
Yeah.
And that's why we have snowflakes that are so beautiful. But
Right.
it's also why we can't use the water for a thermometer.
Right.
Isn't that so interesting?
Yes, very much so. It'd be so convenient if we could use it, wouldn't it be? It's like just very available.
Yeah.
It could be pretty easy to make your own. Be like, hey, just put this exact amount of milliliters in a thingy or whatever.
In a thingy.
But
yeah. And so I was so excited about this. I wonder if we've talked about this before and I said that was my guess, but I didn't look it up. But I was so excited about it. It just hadn't stuck in my brain before. And now I knew as soon as I looked it up, I was like, this is going to be one of those things I think about every time I look at a thermometer. I'm just going to think about it every time. And then I told my roommate and Mason, both of them. Mason's first question was, how do infrared thermometers work? And I said, get out of here. We'll talk about that in 2 weeks. But my roommate, when I told her what was in there, she said, I never even thought. I just assumed that was colored water. And so then I was like, this is so exciting that we get to talk about all these different little pieces of chemistry of why it can't be colored water and why. Yeah. So I thought that was fun.
That's really cool. Yeah.
Yeah.
Man. Yeah, it is very interesting. It's like we're so used to it, especially with the digital kind. Think about, what about a time when you want something, you need to just use nature alone to tell us what the temperature is.
Yeah.
And the fact that someone was so smart to realize that is mind-blowing. Like, if I put this amount of mercury in there, this is what happens. And actually, I could put markings to the side and it would actually show us what the temperature is.
Yeah.
Like, that is so genius.
It's so smart. But now I have another one for you. Okay, so that's the classic water kind. But have you seen the mechanical ones? Like we have one in our oven that's like literally an arrow that points to the temperature.
Yes, right.
Okay, so can you think about how that might work?
Okay. I mean, it has to be so much larger range, right?
Mm-hmm.
That makes me think that it could not be liquid, or if it was, it have to be like really different kind and something I wouldn't even know about. My thought would be it's specifically metal expanding and contracting in a way that is able to measure it.
Yes.
But I don't know why. I don't know how that seems like it would be harder to me to figure out.
Oh my gosh, this is so exciting. This has only happened one other time, I think. Was it on the tire pressure one where you guessed right away?
Yes.
And you didn't already know this one?
No, I did not.
Oh, this is so exciting. Okay, yes. It is. That was it was so fun to see you think about that. Oh, as a teacher, I'm just like, this is so exciting. This is what I want to happen. Yes. Okay, so you were so close. You didn't get it exactly right, but it is metal.
Okay.
And the key is it's two different metals that will expand and contract at different rates.
That's cool.
So when one may be expanding, let's say, and getting bigger, the other one isn't expanding. It's holding steady, but it's welded together so it will make the metal bend. And as that metal bends, then that changes where the pointer is pointing, and you can just calibrate it to say, oh, when it's pointing here, it's at this temperature. When it's pointing here, it's at this temperature.
Yeah.
And so it basically takes the gaining or loss of heat and the changing of the metal expanding and contracting to change its shape. And then when the shape changes, you kind of harness that energy and turn it into a mechanical turning of a dial to tell you how hot and cold something is.
So probably just one time, not one time, obviously, but like the first time, was it a bit of trial and error? Sort of like, okay, we put these two pieces of metal together, and then we put the oven to 400, something like that, and we maybe also independently like verify it. Did we get it there? Okay, now let's have a little less of that metal and see if we can nail it this time or whatever. Just a bunch of like testing to get it right or whatever.
Yeah.
That would seem like it would take forever to figure out. I mean, I guess people who already know way more would have a better first guess anyway.
I think you're right. I think probably like to calibrate all these things together, it does take a lot of like, okay, we're going to heat this to here. And I think that's part of why mercury was initially used. Well, one, it's liquid, and it expands and contracts at a really steady rate. But I think its boiling point and melting point and freezing point give a wider range than like an alcohol would.
Oh, right.
But yeah, I think you have to calibrate all that, to be able to say, oh, this is how much something, this is the temperature here, this is the temperature here, and this is the temperature here,
Mm-hmm.
Same thing with like how much something weighs. You have to like assign a weight value to one thing.
Yes.
And that's why we're going to talk about temperature scales and why different things are what temperature next time.
Got it. Okay.
Oh, one thing we didn't really talk about, we've talked about it before, is what even temperature is. So heat and temperature are two different things.
Right.
Which I think we get conflated because in like common language we say, how hot is it outside? Oh, it's this temperature.
Right.
But heat is energy moving from something with more temperature to something less temperature. So you can think of heat as if you have a hot coffee, the energy it's giving off into the cooler room around it is heat. You can feel it coming off. Where temperature is a measure of the energy currently in the room.
Got it.
Or space or item.
Got it.
So I did want to talk about that.
Wow. I would never really thought about that being different.
Yeah.
But I guess it kind of makes sense too, because what if you had a hot cup of coffee and the room around it was also the exact same temperature? You couldn't feel the cup of coffee be hot.
Yeah.
Because everything's hot.
Yeah.
So you wouldn't even really, I don't know.
Yeah, like when coffee's at room temperature, room temperature is not cold.
Right.
Not like there's no heat in it. It just doesn't feel hotter than the relative surroundings.
It's all relative.
It's all relative.
Wow. Yeah, that's weird.
So temperature is a measure of the sort of like the current heat, the current energy that's happening. Whereas heat in science is defined as energy flowing from one thing to another.
And it wants to do that?
Energy, yeah. It likes to go from high energy to low energy.
So
sort of similar to if you have the hot cup of coffee, it'll try to,
right.
The movement in those electrons will try to match the movement in the room of the electrons around, or not electrons, atoms. I'm in a real OChem brain today, thinking about electrons all the time. So we did an episode about that where we talked about how thermoses keep coffee hot. Way long time ago. And we, at the very beginning of that episode, we talked about why coffee gets cool in the room in the first place.
Right.
So we can go back and listen to that episode if you need a reminder of why that happens. It's all about the electrons or not the electrons. I don't know why I keep saying that. The atoms and why the way they move all around is like bumping into other atoms and giving other atoms their energy, and it just kind of spreads and spreads.
Right. And also, I'm pretty sure we've rebroadcast that one somewhat recently. So it's not too far back in the feed. And maybe like a year ago or something like that. But like it is not, it won't take you tons of scrolling to find it.
Or on Pocket Casts, there's a search feature.
That's
you
right.
You just search within the podcast.
I love that feature.
Yeah, it is pretty handy. I had to convert to Pocket Cast after Stitcher died. It's really sad.
Very sad. I've always been a fan of Pocket Casts. I had Melissa and I would fake fight about this. When Stitcher did die, I tried to be chill about it and was like, hey, Pocket Cast is great. You should check it out. But also, here's a few other ones. But in my, heart of hearts, I was like, please come to the Pocket Cast side.
I just chose the path of least resistance. I was like, this will make Jam happy, and I don't care right now.
Yep.
But I haven't fully committed. Like, I haven't put all my podcasts saved on there. I just have been searching them every time.
Yeah, it would take a bit of effort, wouldn't it?
Yeah.
To just sit down and do that.
And I know what day of the week which ones come out. So
yeah,
I just search them anyway.
Yeah.
So that's it. That's your lesson for today.
Nice. Cool. I like that. A bunch of cool tidbits, all very interesting to me about thermometers.
I think every time I look at the oven thermometer, because it's one with a dial
Mhm.
in our house. I'm gonna think about that. We had to get an oven thermometer because our old oven was 50 degrees too hot, and our new oven turns out is 50 degrees too cold.
I should get one of those. I do actually have a digital thermometer with like a probe that can go in that hot of a situation.
Yeah.
I probably could just like drop the probe in the door and close it
and see it.
and see how hot our oven is.
Well,
See if it's
and our
accurate.
old one, there's also pockets because it wasn't gas. Is yours gas?
Yeah.
I think gas is probably heats more evenly.
Mm.
It's my thought.
Yeah.
But in our old oven, there was like pockets of where the coils were that heated up that made it hotter or less hot.
That would make sense. But I think gas probably has a similar problem.
Yeah, that's our new one.
I bet there's parts that are hotter than others.
You think?
Well, just thinking like, at the very top or the very bottom.
And there's the place where the gas is or not the gas, but the heat.
Yeah. Yes.
But there are gas molecules.
But maybe you're right, or maybe it's moving around enough that to the food it doesn't make much of a difference. But yeah, I'd like to test that now.
Yeah. So get an oven thermometer. It's fascinating. It makes your baking much more consistent.
Nice.
Okay, so that's your whole lesson. And normally I would have you explain it back to me, but you already kind of did explain it back to me.
Yeah, we kind of took little checkpoints along the way
to
make sure I understood it. But that was really fun.
Well, this was really fun. It made me really happy. And I'm like, this is such a simple one, but we haven't had a short episode in a while. So maybe this is like if you're, you're just home from the holidays and it's been kind of crazy early in January. Maybe you're on a walk or something. You just want a little short podcast break. This is good for you.
Yeah.
And I love it when it's like so simple and so powerful. My mind was blown.
Well, temperature, it's crazy because like obviously tons of things are so everyday, and that's like what's so cool about chemistry and the whole point of the show.
Yeah.
But temperature is our lives daily revolve around it.
Yeah.
Not just affected by, but revolve around it.
Yep.
I look at the temperature every single day.
Yeah.
Make decisions about what I'm going to wear,
Yeah.
All that kind of stuff. It's like we daily need to care about it.
Yeah.
If you don't at all, you will find yourself making a mistake of some kind. So it's like kind of cool to get into something that fundamental. And the way we even know what the temperature is, like, oh, of course we had to figure that out at some point so we could know it and have it on our phones and watches.
And next week, we're going to talk about how, if I can figure out infrared thermometers, we'll talk about that. I bet I can. But also, how did Fahrenheit and Celsius even come to be?
Mm-hmm.
Why are they the numbers that they are? What are the values of each scale? And a little bit of history to it.
Nice.
So that'll be temperature part 2.
Nice. And I bet I know why Mason asked about the infrared. I mean, he's a curious guy.
Mm-hmm.
But our roaster has an infrared thermometer in it, our coffee roaster.
Oh, really?
Yes, it has two kinds of probes. It has a sort of standard, like just metal kind of like probe stick.
So that one probably is the bimetal. Oh, well, maybe not if it's to a digital readout.
It is to a digital readout. But it has that.
I should look into that too if they use the same technology or not.
There's one that's like that, and then an infrared one. The cool thing about the infrared one is it is pointing the infrared, beam or whatever at the coffee beans.
Mm-hmm.
And so it is getting a reading of the surface of the beans, how hot they are. And the probe is sort of getting the temperature of just the air ambiently in the drum.
Yeah.
Because it is trying kind of not to be hit constantly by the beans because that might not be good over time. So it's 2 different temperature readouts.
Wow. Do they come close together often?
Eventually they do.
Yeah, I would expect the coffee to start colder.
Yes, they kind of do this thing and then they intersect and they cross paths a little bit as the beans get hotter and you ease off the roaster's heat level. The beans are still hotter.
That's cool.
Yeah.
I'll look. I didn't think about probe thermometers. We do have one of those too, and I wonder how they get converted to the digital readout.
Yeah.
So I'll look into that, both of those, infrared and the probe,
okay.
and then we'll also talk about where Fahrenheit and Celsius come from.
Okay. Cool. That sounds great.
Yay! Fun. So I was really excited about this episode, and it made me really happy. So thanks, Letila and Ebony, and whoever asked. Apparently a Q&R question a long time ago. For some reason, that didn't hit the same way it did today. Who knows? Maybe I was in the throes of grad school. So anyway, that made me really happy. But what made you happy this week, Jim?
Oh, you're using that as your happy thing?
No, I just wanted to use that to transition.
Nice.
A smooth transition.
That was very smooth.
Thanks.
Something that is making me happy this week. Do you already have one in your mind?
No, I don't.
Okay, I got one.
Okay.
So, I am revisiting a TV show right now with my mother-in-law and my wife.
Both of you?
Yes, we're
That's
watching it
cute.
together.
So all three have to be home.
Right. Which does make it a little bit hard, but kind of fun. The category of things that like kind of cross section of all of our interests. Already my wife and I have very different TV show interests, but we have found plenty. But it's just like there's also plenty that I like that she doesn't like, and vice versa. So that's already one. You get this sort of triple Venn diagram situation going on. I remember
That's
this
called a Euler diagram.
Nice. I think in that one time, that one time I used one in that talk I was giving. I titled it a Venn diagram, Venn diagram, just to be funny.
Yes.
But
I was like, haven't we talked about this before? Yeah, I think you used a presentation, and I was like, that actually has a name.
Yeah, I think I did 4 of them, and so there was like you could have, yeah, but you had to make it to where 3 of them could overlap without the 4th one.
Yeah,
it's very hard for me to make it on my computer.
I use a computer to do that for me, a program.
Yeah, I probably should have too. I just did it on the computer, but I moved the circles by hand.
Yeah.
Anyway.
Sorry.
This show is cooler than Venn diagrams are. I remember this show.
Depends on who you ask.
Yeah. I remember this show that I watched years ago now. It's been like quite a while that I thought, oh, I really want to rewatch that. I kind of forgot about it. And I really think that it actually would hit all 3 of us and like overlap in our interests of shows. And the show is called 11/22/63. Have you heard of this? The date 11/22/63. Do you know what happened on that date? Just think about it for a second.
11/22. So November 22nd, 63. 60 is a civil rights movement. Is that one MLK? No.
You're getting close though. Sort of.
Does it have to do with the civil rights movement?
Only sort of. Not.
Did somebody else get assassinated that day?
That's not the same day as MLK's assassination, but you are on the right track.
That's what I mean. Yeah, did somebody else get assassinated in that time frame?
Big one.
JFK?
Yeah.
Right
JFK.
here in Dallas.
Mm-hmm. Right here in Dallas, Texas. Mm-hmm.
I've never been to the museum, but I really want to go.
I want to go to the museum. I have not been there either, but I've driven right near Dealey Plaza where that happened, and I remember driving near it and being like, "Wait, that's the place!" Like I just like wasn't even trying to.
It's weird that you could still go there.
Yeah.
Yeah.
So, I mean, it's just like a little underpass area. Anyway, so I watched this show years ago. It's based off a book, Stephen King book, different than some of his normal stuff. And it's about a guy basically has this theory that if he could prevent JFK's assassination, many things about the trajectory of the United States would go much, much better. And he has all these reasons for thinking this, both like civil rights movement related and Vietnam War, just negotiations with, Cuba and the Cold War that was happening right then too. A lot of those kinds of threats of nuclear, whatever, and many, many other things. And then he kind of has charted a lot of like, if that hadn't happened, then this might not have, and basically thinks that the world would be a much better place. And so without spoiling too much.
Does he make a time machine?
No, actually.
Oh.
It happens differently than that. But there is time travel. And the whole premise is around like trying to investigate but not be and change things, but be careful and also just observe. And so it takes place here in Dallas, which is cool.
That is cool.
In the 60s. And it's a really good show. It's like just one season show.
That seems like the kind of show I would like too.
Yeah, you probably would. I mean, it's intense. There's some thrilling parts to it, of course, but like it's also got the mystery, the kind of like solving a problem mission feel to it a little bit. Yeah. Anyway, very, very good. And so far been a big hit with all parties involved. So I've been enjoying rewatching that.
I read a book when I was in, I think it was elementary school. I was pretty young, about one of the reporters who was there for JFK's assassination and what the newsroom was like. And it was like a big book, kind of like picture book.
Uh-huh.
I have it on my Goodreads, so my phone's over there. Anyway, so yeah, and I remember being so fascinated, and for a while after that, I thought I wanted to be a reporter because it was so interesting to hear about that.
Yep.
So yeah.
Yeah.
That's on my to-do list, is to go back and read that and try to like remember why it impacted me that much when I was young. But yeah, so that sounds like exactly the kind of show I would like.
It's good. It's on Hulu. It's good.
On Hulu. Okay, great.
Yep. So
Not a sponsor.
Yeah, not a sponsor. What about you?
Okay, I thought of something sort of while you were talking, like right at the beginning. I was paying attention, I swear. So our house is kind of coming together. We recently moved.
Right.
And we have a roommate, and so it's been kind of, sometimes it's hard because you're like trying to figure out what they need and what you need and, you know, whatever. So we kind of have, our room is only our space. And we got this old chair. Did I talk about that on the podcast, that I was going to like sort of restore it? I know you knew.
I can't remember if we talked about it on the podcast or we just talked about it separately.
It took hours, man, because it was dirty when I got it. But it was this really cool color. We like took out some of the cushions and replaced it. And so the chair is like restored and it's clean and it's in my room. And that's really exciting. And we added legs to it. And there was a button missing. So we like kind of repaired that. And yeah. So my room is like come together, and I was looking at it the other day, and I realized it's kind of the first time I've gotten to try out like what is my design style. And a lot of things I borrowed from y'all. My Emily used to say she wanted the room to feel like it was hugging you when you walked into it. And I feel like that's really accurate to how I feel in my room. But we've got our matching mid-century modern nightstands that like we thrifted both of them separately, and they are a set, which is amazing.
Nice.
And we got little, those are dressers, and then we have nightstands that match too. And we've just had like hand-me-down furniture this whole time, that it's been a hodgepodge. I didn't even have a nightstand in our old apartment. There wasn't room for it. And then, you know, we have the rug that we stood on for our wedding is a rug that's on in our room. And then we have some shelves with like all these little sentimental things on display where like we get to look at them, like stuff with my mom, stuff with Mason's dad, stuff. Yeah. Just like stuff from our wedding, that it's like, these are the things that are important to us, and we get to look at them. And yeah, so it's nice to kind of find what's like, oh, I like splashes of color, but mostly neutral. And then like, so like a lot of the little decorations have color, and the rug is nice color, but like our bedspread is white. It's just nice. It's like I get to walk in there and be like, yeah, this is what I want my room to look like.
Yeah.
And I think before, you know, I always had roommates, and so it was hard to invest in spaces because you know you're just going to move again at the end of the year.
Yeah.
Or I didn't have money because I was in grad school, and so or it was like, we're in this apartment, it feels really temporary. There's not a lot of room in this room, so there's not a good point there. So we're still renting, but I think because we know, oh, we're going to live together forever.
Yeah,
you know, it's not just that we can take these pieces and incorporate them into our next house too.
Yep.
So these are the things we're going to have in our bedroom long term.
Yeah.
We can invest in the things that we really want. And so it's just really fun. It's like the first time I remember being able to walk in and be like, yeah, this is what I want my room to look like.
Yeah.
It looks exactly like I want it to look.
That's great.
It's
Man,
cozy.
That's so nice.
Yeah.
And it's cool to, I mean, obviously it slowly comes together. It's kind of cool to like look around and be like, whoa, it's happened.
Yeah.
Or it's very much happening. You know, it's like every small thing kind of nets this very different experience.
Yeah.
Yeah.
And in the office too, there's a little space with my desk and a wall behind it. And I have an office chair and a desk and shelves with like stuff that pertains to my work and stuff that I love on display that can be on the Zoom meeting behind me instead of like my bed or some doors.
Yeah.
It's just so nice. I've never had my own office chair before.
Nice.
It's just like, wow. So that's been making me really happy, is that I feel like our room and our office / guest room is finally sort of coming together, and I have space.
Nice.
So that's really exciting.
That's awesome. Very cool.
Yeah. All right. Well, thanks for coming and learning about thermometers, and for being such a good student that you've learned so much chemistry that you were able to figure that out. That makes me so happy.
Thanks for teaching us. Thanks for teaching me. Thanks for setting it up over many lessons so that I could knock this one out of the park, you know?
Yeah, you did. You knocked it out of the park.
But thanks for doing that. Sort of, you know, planning out that way and making me look good, you know?
That's my whole goal with this podcast.
And thank you for the questions you guys send in and ideas for topics you guys have. We love y'all's ideas. Send those to us on our website at chemforyourlife.com. And those are great for even like for potentially an episode idea like this one, or just a follow-up like Melissa was saying earlier that we can talk about on our Q&R episodes and go a little deeper on certain topics and stuff like that. So please send it to us, chemforyourlife.com. If you'd like to help us keep our show going and contribute to cover the cost of making it, you could join our super cool community of patrons on Patreon. That's patreon.com/chemforyourlife to join and help keep the show going. If you're not able to do that, you can still help us by subscribing on your favorite podcast app, rating and writing a review on Apple Podcasts, and also by subscribing to our channel on YouTube. Those things help us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. Jam Robinson is our producer, and this episode was made possible by our financial supporters on Patreon. And one of the suggestions for this episode was from our supporter on Patreon, Letila. So we love that. We love so much that you want to help make chemistry accessible for even more people. And just to shout out those supporters, they are Avishai B, Bri M, Brian K, Chris and Claire S, Chelsea B, Derek L, Elizabeth P, Emerson W, Hunter R, Jacob T, Kristina G, Katrina H, Letila S, Lynn S, Melissa P, Nicole C, Rachel R, Sarah M, Stephen B, Shadow, Suzanne P, Timothy P, and Venus R. Thank you again for everything you do to make Chemistry for Your Life happen. And an extra special thanks to Bri, who often creates illustrations to go along with the episodes of Chemistry for Life. You can see those on our YouTube channel.
And if you'd like to know more about today's chemistry lesson, you can look at the references for this episode in our show notes or in the description of the video.
Yay, chemistry! Yay, thermometers!
Yay, chemistry!